Okay, continue. So let's see example 1 for reciprocal function. Let's say you're given function fx equals to 4 minus 3 over 2x plus 2. So in these functions here, if you notice, I can rearrange in such way that I have the constant 4, I move behind, and then the negative sign, I go on with the terms 3 on top here, the constant 3 on top here. So it gives me negative 3 over 2x plus 2 plus 4. Therefore, it happens to be fulfill the form that we need for the reciprocal function, where this is the step 1. We determine the type of the function. Where I want the type of function, it happen to be fulfill the requirement in these functions in general here. So with that, I find out that the A is corresponding to negative 3, M is corresponding to 2, and C is corresponding to 2, your K is corresponding to 4. And in here, you see that I happens to consider A divided by M because this will be useful later to determine the shape of the graph. And this is actually important to take notes on the next step there. So anyway, the important thing here is that step 1, you're able to identify the function that given is happen to be fulfill the shape that we have. This AMCK is just for you to realize the comparison compared to the general formula for further calculations later. Then we go on with step 2. With such arrangement that I happen to have now, I want to decide what is the shape that I have. So the decision of the shape you're referring to, I have my A and M. When the time I do divisions, what will happens to be the result, whether it's positive or negative. So the A will refer to the constant on top here. This is referred to the A. The M will refer to the coefficient of the X. Therefore, by referring to here, I have my A equals to negative 3, M equals to 2. The division, it gives us negative 3 over 2, which is less than 0. So from there, how are we going to decide our shape of our graph? So once again, the shape of each type of function, we just need to remember one of the cases. The other cases, it just happened to be followed through only. For example, in the case of reciprocal, I want to remember the case of A divided by M is the case of I have greater than 0. Then the shape will happen to be focused on the first and also the third quadrant. So if let's say now I want to convert to the case of less than 0, I want to get the case of less than 0. What will happen is that I will consider now the graph that I have moved to the second and fourth quadrant. And as a result, you shall see that this is what we have now. So you see the graph now moved to the second and the fourth quadrant for the case of less than 0. And please be aware, the dotted line here is referred to the asymptote. And what is the idea of asymptote is that your graph is getting closer and closer to the asymptote as the part that I circle, but your graph will never ever touch the asymptote. It won't touch the dotted line asymptote. Please be aware of that. Okay. Come up to here, I already know the shape of the graph. The next thing what I want to do is that I want to decide what is the coordinate of the special line. So in here, the special line is referred to the vertical and horizontal asymptote, which is the dotted line that I have in red and also in purple. So I label in red for vertical asymptote, in purple for horizontal asymptote. And how we happen to get the answer, let us begin with the calculation of the vertical asymptote. To get vertical asymptote, I focus on the denominator where I have the function of 2x plus 2, the linear function, the linear expression. I make it equal to 0. I get x equals to minus 1. So this will happen to give me what is the answer for the vertical asymptote. Whereas from the value x, from the value plus 4, it will give me y equals to 4, where this will correspond to our horizontal asymptote. So therefore, it gives me the answer now. I have my vertical asymptote as x equals to negative 1, y equals to 4. So the asymptote here is not refer to a coordinate. Jadi jangan buat dalam coordinate. Dia refer kepada satu garis. Then the line, the garis is happen to be defined as x equals to -1, y equals to 4. Then go on. By right reach until this step here, it should be good enough for us to determine what is the domain and range. Again, from here we can determine what is the domain and range. So we have vertical asymptote x equals to -1, horizontal asymptote y equals to 4. So by referring to this framework here, we should able to find out that the domain of this graph here, we see how far the graph can cover along the x value. That means kita nak tengok kalau graph ini kita extend, sejauh mana dia boleh pergi secara melintang. So we notice that it can go all the way to -infinity. And this part here, it go very close to x equals to -1, but it never touch. Dia tak akan sampai -1. So maka dari sini kita nampak I can have the domain from -infinity until somewhere very close to 1, but not include 1, so open bracket. Beside that, I have also graph at this part here. It's also getting very close to -1, but never touch, and all the way to positive infinity. So therefore, the answer is anything on the real number except -1 for the domain. Kita tak ambil nilai x equals to 1. Whereas for the range, kalau you berminat untuk cari, we see how far the graph can extend vertically. So it can go all the way from 4 to positive infinity, all the way go down from 4 to -infinity, but the graph will never ever touch 4. So therefore, the answer, -infinity until 4, not include 4, union 4 until infinity. If let's say you're interested to find out the domain and range. Then without further ado, we go on with the x and y intercept. And we would like to check whether they exist or not by doing a rough sketch. Put in the x and y axis, and then we put in our asymptote and graph. So from the rough sketching here, we can somehow see that we are going to have both x and y intercept where it happens to be located somewhere here. But whether is this a correct position or not, we are not sure. But for sure we know is that x and y intercept exists. We need further calculations to verify their location. So by calculation for y-intercept, we let x equal to 0. I have my fx equals to 5/2, which implies that my y-intercept is 5/2. So therefore, I will happen to have my y-intercept cut at 5/2. So obviously lah, kalau you tengok balik this rough sketching here, dia sentuh pada tempat yang salah sebab dia sentuh pada y yang negatif. Again, tak apa, this rough sketching is just happen to tell us whether x and y-intercept exist or not. Actual location masih perlu kiraan. X-intercept, we let the fx equal to 0 or y equal to 0. We find out x equals to -5/8. Jadi again lah, the sketching here ada kesilapan. For the rough sketching ada kesilapan, tapi tak apa. Sekarang based on the calculation, we group all the information in step 1 until step 4. We have our graph done. So this by right is the graph that we have. After we find the correct position of x and y-intercept, then kali ini, in step 5, jangan label salah, jangan intersect salah, sudahlah. So we put in all the informations, and we have done our graph. And once again, the reminder, make sure you label the x and y-intercept, label the x and y-axis, label the origin, label the graph, label the xy-intercept, and also the special line here, which is the asymptote. So asymptote, horizontal asymptote, y equals to 4. Vertical asymptote, x equals to -1. So therefore, we have complete our graph for this reciprocal function, example 1.